All right. 6.1 random variables. Chapter 6 is all about discrete probability distributions. So we start with 6.1 random variables, and these are the objectives. It's a lot. So, but these are short ones. So number one, distinguish between discrete and continuous. You learned that back in chapter one. It's just still the same thing. Number two, determine a probability distribution for a discrete random variable. Number three, uh, between probability distributions and populations. Then you're gonna learn to construct a probability histogram. So when you learn histogram, it's still gonna be the same thing. And the last part, computing the mean and the variance and standard deviation of a discrete random variable. All right, so what's the difference between discrete and continuous again? Do you remember from chapter one?
Discrete is like only one number, and continuous is like you can change it.
What do you mean? What do you mean?
Like
There's
if somebody's like 5'4", right? They give you like 5'4.1111.
Is that right?
Right. This is the opposite.
Any other answers about the difference between discrete and continuous?
Discrete is like possible values can be listed, and then the continuous is like it can take on any value.
Yes, that is correct. Or discrete, like the easiest way to remember it's countable. So if you can count it, then it definitely it's discrete.
Okay.
So just like since we're talking about random variables and this is still about probability, so an example here, if you roll a fair die, the possible outcomes are the numbers 1, 2, 3, 4, 5, and 6. And each of those numbers has a probability of 1/6. So rolling a die is probability experiment whose outcomes are numbers. Sorry. So the outcome of each of such an experiment is called a random variable. So take note of this. So random variable is a numerical outcome of a probability experiment. So discrete and continuous to discrete are random variables whose possible values can be listed, like what you said. So examples are the number of, that comes up on a roll of a die, or the number of siblings a randomly chosen person has. And continuous, those that can take on any value in an interval. So an example, the height of a randomly chosen college student, or the amount of electricity used to light a randomly chosen classroom. So just to recall those two types of variables. The next is determine a probability distribution for a discrete random variable. And if you want to copy this, you can copy it now. So probability distribution for a discrete random variable, specify that probability for each possible value of the random variable. And take note of the two properties here. You already know that the probability is the answers for every possible of x. That's always from 0 to 1. And the summation of probabilities should always equal to 1. So probability is between 0 and 1, and the summation is equal to 1. So just like this example here, so let's check using those two properties to decide if the following represents a probability distribution. So as you can see here, your probabilities here 0.25, 0.65, negative 0.30, and 0.11. So we have a negative here, so that's why this is not a probability distribution. Because remember, it should always be between 0 and 1. Okay? How about this? Is this a probability distribution? This is a probability distribution. So look at all these probabilities. Those are between 0 and 1. And when you add all these numbers is equal to 1. Well, this one. What do you think?
No, because it adds up to more than 1.
Yes, or just the very first one. P of 1 is 1.02 because your probability should be between 0 and 1 only. Okay, so next example here, 4 patients have made appointments to have their blood pressure checked at a clinic. Let X be the number of them that have high blood pressure. The probability distribution of X is as follows. And as you can see here, first, is this a probability distribution? Yes, since these are all between 0 and 1, and 4, 6, 7, 8, 9, and the total is 1.0. So how do we find the probability of 2 or 3? So remember, addition rule, 2 or 3. So meaning you just have to add the probabilities of 2. The probability of 2 is 0.27. Probability of 3 is 0.08. So the answer here is 0.5. Next, how about using the same table here, find probability of more than 1. So what do you mean by more than 1? More than 1?
So 2, 3, or 4?
3 or 4. So meaning probability of 2 plus probability of 3 plus probability of 4. So when you add all those 3's, it's 0.27, 0.08 plus 0.01, 0.36. At least 1. You learned yesterday about getting the probability of at least 1. You remember at least 1 is greater than or equal to 1. So meaning from 1 to 4. You can add all this, or you learned yesterday that to get the probability of at least 1, this is like 1 minus probability of 0. Remember this yesterday? So we have the probability of 0 here, which is 0.23. 1 minus 0.23 is 0.77. So you can check, since you know that at least 1 is greater or equal to 1. So when you add all these 1, 2, 3, and 4, it's going to be 0.77 also. Any questions?
No.
All right, so next objective, describe the connection between probability distributions and populations. Okay, so statisticians are interested in studying samples drawn from populations. Random variables are important because when an item is drawn from a population, the value observed is the value of the random variable. And the probability distribution of the random variable tells how frequently we can expect each of the possible values of the random variable to turn up in the sample. So just like an example here, who wants to read this example? Volunteer.
I'll read it. An airport parking facility contains 1,000 parking spaces. Of these, 142 are covered long-term spaces that cost $2 per hour. 378 are covered short-term spaces that cost $4.50 per hour. 423 are uncovered long-term spaces that cost $1.50 per hour, and 57 are uncovered short-term spaces that cost $4 per hour. A parking space is selected at random. Let X represent the hourly parking fee for the randomly sampled space. Find the probability distribution of X.
So to find the probability distribution of X, just like the previous examples, the table, so you just have to create X and P of X. So X, the random variables should be numbers. So we have here, $2, you have $4.50, you have $1.50, and $4 per hour. So those are the costs. So if I arrange it, so we have 1.150, $2, 4, and then we have to get the probability of each. So let's say if you want start at 150. So you have 423 different colors. So 423 uncovered long-term space that costs $1.50 per hour. So that is like 423. The probability that it is 150 is 423 out of the total 1,000. Next, $2. So 142 are covered long-term spaces, and it costs $2 per hour. So that is 142 over 1,000 is equal to 0.1. Next, 57 are uncovered short-term spaces that cost $4 per hour. So that is 57 out of 1,000. So that is 0.057. And the last one, 450, we have 375 are covered short-term spaces that cost $4.50. So 78,000 is 37. So this is our probability distribution. You have the column X and P of X. Okay. So you're gonna see it here. So this is our probability distribution. Any questions? So next one is we're gonna use this probability distribution and construct a histogram. For that, the mean is a random variable. We compute, you know how to compute the mean, right?
Yes.
So the probability distribution for the mean is usually difficult to compute. We will learn a way to approximate this when the sample size is large in a later chapter. So we're going to discuss this later. Okay, next is construct a probability histogram with our probability distribution. So just like an example here, so let's say we have the probability distribution here, you have X and P of X. It's the same thing how you construct your histogram. So let's say probabilities as your y-axis. So 0.03125 is the first bar here. Then 0.15625, 0.31250, and the last one, is that 125. Yep. All right, so how do we compute for the mean of a random variable? So we have a formula here. So copy this. It provides us the measure of center for the probability distribution of a random variable. So all you have to do, remember, you have your X, your frequency distribution, you have X and P of X. So you're gonna create a third column, X, P of, you multiply these two, and then the total here, that is gonna be your mean of a random variable. So just like an example here, so computer monitor is composed of a very large number of points of light called pixels. It is not uncommon for a few of these pixels to be defective. So let X represent the number of defective pixels on a randomly chosen monitor. And given the probabilities here, so find the mean number of defective pixels. So again, the mean is so it's you multiply X and P of X. So 0 times 0.2, 1 times 0.5 plus 2, 3 times 1. So get your calculator and compute for the mean. What is the answer?
1.2.
Questions?
No.
All right. So next one. So yeah, computed mean is 1.2. So next one, expected value. So there are many occasions in which people want to predict how much they are likely to gain or lose. So often this is done by computing the mean of a random variable. So the expected value is simply, again, finding or computing the mean. And we use notation as E of X. So, and take note of this, if the expected value is positive, it expected a gain, and then if it's negative, then it is a loss. So just like an example here, mineral economists estimated that a particular venture had a probability of 0.4 of a 30 million loss, probability of 0.5 of 20 million profit, and probability of 0.1 of 40 million profit. So let X represent the profit. So find the probability distribution of the profit and expected value of the profit. So find the probability distribution. It's just like our X and P of X. So you have a $30 million loss. That's why it's going to be a negative, and the probability is 0.4. Profit, that is going to be positive. So that's, and you have a probability of 0.5, and another one, 40 million, with a probability of 0.1. And then the expected value is solving for the mean. So remember, expected value is also the mean. So you multiply your X and P of X. So negative 30 times 0.4, 20 times 0.5, and 40 times 0.1. When you compute this, it's going to be equal to 2.0. So that is positive. So you expect a gain of $2 million. If you have any questions, let me know. Okay, and the last one here is variance and standard deviation. So you have all these formulas here. What we know about variance and standard deviation, whenever you have a variance, get the square root of it. Square root of a variance is a standard deviation. Or if you have a standard deviation, square it, you will get the variance. But don't worry, I'm not going to ask you to memorize all these formulas, because I allow you to use the graphing calculator. So we will use that to get the answers. Even for mean, if you don't remember that mean of X is equal to the summation of X times P of X, it's okay, because we're going to use a graphing calculator. Okay. Let's try that. Okay, so I want you to get your graphing calculator and enter these numbers into L1 and L2. This should be your L1, and and this should be your L2. All right, so next is to get the mean and standard deviation. So try this tab. The right calc, and then here you'll see so the default is you have L1 here and you don't have anything here, but this time you have to make sure that this is L2. So to do that, L2 is second 2. To get L2, that is second, and then calculate, and you will see the answers. So here, mean of all this is the X bar, which is 1.2. You see that? And the standard deviation, what is the standard deviation?
Zero 0.872.
0.87. Get this?
Yeah.
And if I ask you, let's say variance, all you have to do is square this, right? Any questions? Any questions?
No.
Oh, that's it for 6 point. Okay, let's have more practice. So again, when you check your Connect Math, you should see homework assignments, 5.3 and chapter 6. And again, the videos are optional. 3 of you already, when I checked this morning, already started working on the assignment. So chapter 6, actually, when you go to your ebook, when you click on the media, you will see all those videos. It's the same thing. I'm just assigning it to you just to make sure if you want to watch those videos. Okay. So let's try. Okay, let's start with 27. So this is going to be fast. So determine whether the table represents a discrete probability distribution. So just yes or no. And if not, explain why not. What can you say about number 27? Is it a probability distribution?
Yes.
So yes, you see probabilities between 0 and 1, and when you add up all these numbers is equal to 1. How about 28?
Yes.
Yes, same reason. 29. Yes or no?
No.
Not. Because
It doesn't add up to 1.
0.1, 0.1, 0.1, 0.1 is 0.4. 30. Yes or no?
No, because there's a negative number.
That's correct. 31.
Because it's over 1.
1, 2.
Yes.
All right. Okay, so next one, let's try 45. Okay, so the federal government has enacted maximum allowable standards for air pollutants such as ozone. So let X be the number of days per year. The probability distribution of X is given by, so you have this table here, and please get your calculator and enter these numbers into L1 and L2. The same thing here. 0, 1, 2, 3, 4. All right, so let's answer first. Letter A. Probability of 1 is
0.38.
P of 1 is 0.38. That's correct. Next is 3 or fewer. 3 or fewer meaning less than or equal to 3. So 3 or fewer is. You agree? Less than or equal to 3. So you can add all this, which is, when you add is 0.96, or if you want, you can solve it this way, or complement of this is 1 minus probability of greater than 3, and greater than 3 is probability of 4 is 0.04. That's why it is also equal to 0.96. How about letter C? At least one day. At least 1 is, again, greater than or equal to 1. Remember, at least 1, we get this 1 minus probability of 0. And that is 0 is 0.33. The answer is 0.67. Or if you want greater, since you know that at least 1 is greater than or equal to 1, you add all this, and it's going to be equal to 0.67. D, more than 2 days. Probability of more than 2 days. Greater than 2. So what do you mean by greater than 2?
Three or four, so we add 0.06 and 0.04.
3 or 4. 0.06 and 0.04 is 1. Okay. Then next, compute for the mean and the standard deviation of this distribution, probability x. So you enter into L1 and L2, stat calc 1. So make sure that you have list L1 and frequency list L2. What is the mean and what is
So 1.1.
that's correct. And the standard deviation is
1.054.
all right. Thank you. Any questions? One more. 51. Sorry. So read 51 and try to solve this on your own. 2 minutes. It's just like what we did for expected value. Do you have an answer? So you pay $1 and pick a number from 000 to 999. If your number comes up, you win $500, which is a profit of $4.99. If you lose $1. So your probability of winning is 0.001. Anyone who has an answer for 51? What is the expected value of your profit? Anyone? Is it an expected gain or an expected loss?
A loss.
Of what?
Is it 0.5?
How?
So we have 0.001 chance of winning 499, so we multiply those. And then add 0.999 times -1, and then combine those.
And that is a negative 0.5. Okay, so that, yeah, that is a loss. Okay. So if you want to try, you can do the same thing for 52. How about 57, last one. Business projection. An investor is considering a $10,000 investment in a startup company. She estimates that she has probability of 0.25 of a $20,000 loss, probability of 0.2 of a $10,000 profit, 0.15, 50,000, and 0.4 breaking even, meaning 0. Then compute for the expected value. You have an answer? So just like what we did earlier, probability of 0.25. So you just have to multiply this. So that's a loss, that's a negative. Probability of 0.2, you multiply that. Probability of 0.15 and 0.4, so 0. Or if you want, just like what we did earlier, to make it clear. So let's say 0.25, that's 20,000. So when you solve for the expected value, so when you multiply and they add all this, what is the answer?
Is it 4,500?
4,500, yeah. Would you advise investor to make the investment? Yes or no?
No,
Ah,
because she's losing money.
are you losing money here?
Uh,
Yes, it's a positive. So you're gonna gain a 4,500, right?
oh, yeah.
Okay. So yes, you're gaining 4,500 here. Okay. Let's continue our lecture, and we're gonna have more practice tomorrow. The next binomial distribution 6.2. Objectives, determine whether a random variable is binomial. Then next, determine the probability distribution of binomial random variable. Then compute the binomial probabilities. And again, compute for the mean and the variance. Okay, so suppose that your favorite fast food chain is giving away a coupon with every purchase of a meal. 20% of the entitle you to a free hamburger, and the rest of them say better luck next time. So 10 of you order lunch at this restaurant. Suppose you want to know the probability that 3 of you win a free hamburger. So how are we going to solve that? We use a binomial distribution for this and copy these properties, conditions to check binomial distribution. So a fixed number of trials are conducted. So just like that example, you have 10 trials, and there are two possible outcomes, success or failure. And for that example, when you get a free hamburger, so that is a success. Otherwise, it's a failure. So the probability of success is the same on each trial. All trials are independent, and the random variable x represents the number of successes that occur. So we use these notations. N is equal to number of trials, and P is the probability of success. Let me know when you're done. Elizabeth is done. How about the rest?
Done.
All right. Try these examples using those conditions. Okay, so a fair coin is tossed 10 times. Let x be the number of times the coin lands heads. Is this a binomial experiment? So using those conditions that you copied, so when you toss a coin, each toss is each toss is a trial, and there are two possible outcomes, heads or tails, right? And all those trials are independent. And let's say that x with the number of times coins lands heads. So when it's heads, then that is a success, and tails, that is a failure. And so that's why this is a binomial experiment. How about number 2? 5 basketball players each attempt a free throw. Let x be the number of free throws made. Is this a binomial experiment? What do you think? Yes or no?
No.
So this is not a binomial experiment because the success here is different from player to player. So making a shot, unlike the heads, is always going to be 0.5. So they will not all be equally skilled at making free throws. So that is not a binomial experiment. How about this? Number 3, 10 cards are in a box. 5 are red and 5 are green. 3 of the cards are drawn at random. Let x be the number of red cards drawn. Is this a binomial experiment? Will you always get the same probability of success?
No.
Why not? So remember, this is like an example that I gave you about the marbles, the blue and green. So you have here red and green cards. So let's say when you pick red the first time, then the next one is not going to be the same because 5 out of 10, and then the next one is going to be 4 out of 9, right? So that's why this is not a binomial experiment. The trials are not independent. All right, so next one, how do we determine the probability distribution of a binomial random variable? All right, so example here, considering the binomial experiment of tossing 3 times a biased coin that has a probability of 0.6 of coming up heads. So let x be the number of heads that come up. if you want to compute P of 2, probability of 2, that means that exactly 2 of the tosses are heads. And there are 3 arrangements of 2 heads in 3 tosses. So first, what are the possible outcomes when you toss a coin 3 times? So, like, I'm just gonna list down like the possibilities. So let's say so these are all the possible outcomes when you toss a coin 3 times, either 3 tails or 3 heads. And meaning to compute that, since it's either tails or heads, and 3 times to 2 cubed, that's why is equal to 8. So you have 8 possible. So here, if you want to compute the probability that exactly 2 of the tosses are heads, exactly 2 tosses are heads, HHT, HTH, and THH. So that's why you have this. So when you compute for that probability, since given here the probability that comes up head is 0.6, so HHT is, this is 0.6 times 0.6, complement of 0.6 is 0.4. That's why we get this. Then same thing here, 0.6, 0.4, 0.6, 0.4, 0.6, 0.6. So meaning you have 2.6 and 0.4. Do you agree? So that's why we have here 0.6 squared times 0.4. And we have a formula to compute for probability distribution. You don't, I don't want you to copy this because I'm not gonna ask you to use this formula. We have graphing calculator to solve this, and we skip 5.4 to compute for combinations. So we're not gonna use this. Okay, but how do we use our graphing calculator? So there are objective 3 is by using 3 different ways here. We have hand computation. Hand computation is by using the formula. So we're not gonna do this. So you can skip this. By the way, we're gonna solve the same examples here, A, B, C, and D. Just showing you using the formula. Long. You can also use tables, and we're not going to use this because I'm not providing you a table, although you have a copy. If you have a book, you have the table just to get the answers. But what we're using is a TI-84, okay? All right, so here, take note of this. We're going to use binom PDF if it's equal to the specific value. Binom CDF if it's less than or equal to this specified value. How do we get binom PDF and binom CDF? So second vars, and scroll down, you will see binom PDF and binom CDF. Okay. All right. So this is the same example using the formula and using the table, but we're using your graphing calculator. So the research center recently reported that approximately 30% of internet users in the US use the image sharing website Pinterest. So suppose a simple random sample of 15 internet users is taken, use the binomial probability distribution to find the following probabilities. So we're gonna solve A, B, C, and D. A is the probability that exactly 4. Next, fewer than 3. Letter C, more than 1. And letter D, between 1 and 4 inclusive. So what do you mean by exactly 4? Meaning equal to 4, right? P of 4. Fewer than 3 is less than 3. More than 1 person, so we need to solve greater than 1. And between 1 and 4 inclusive, so 1, 2, 3, and 4. So let's try this. So given first, you have a simple random sample of 15, so that is your n, and the probability is 30%, so that is p is equal to 0.3. Okay, so find the probability exactly for of the sample people used Pinterest. So exactly 4. So to get this, use binom PDF if it's exact number. So try this second vars. Scroll down, look for binom. So when you will see trials, probability, the x value. So trials is your n. So we have 15 here. Probability given is 0.3. X value is this. So this p of x. So your x here is 4. So enter those numbers and you will get the answer. What is your answer? Come on, all of you try. Second vars binom PDF, and then enter these numbers. 15, probability is 0.3, x value is 4, and you'll be able to get the answer, the probability. Yeah, 186, that's correct. Okay. Next, letter B is fewer than 3 So you can solve this either, we know that less than 3 is our P. Do you agree? Or P less than 3 is the same thing as less than or equal to 2. Do you agree?
Yes.
Less than or equal to 2 are these numbers, P of 0, P of 1, and P of 2. Yes? And if it's less than or equal, so meaning we use less than or equal, we use binom CDF. So you do the same thing, second vars, scroll down, look for binom CDF. So you're gonna see the same thing, trials, P and X value. So trials, yeah, P, you have given 0.30, and the X value here is 2. Because now that is your X here, less than or equal to 2, so this is your X. Okay, so 15. And what is the answer?
Is it 0.0916?
No. Yeah, it's 0.1268. Yes. All right. Letter C. More than 1. Meaning greater than 1. How do we solve this? So find the probability that more than one person uses Pinterest. So if that's greater than 1. So greater than 1, that is 1, 2, 3, 4, right? But we don't know when to stop. But we know that the opposite of greater than 1 is this is the same thing as minus 1 minus the complement of this. What is the complement of greater than 1?
Less than 1?
Less than or equal to 1. Okay? So less than or equal to 1, that is 0 and 1. Again, just to show you, say 0, 1, 2, 3, 4, 5, 6, for example. Greater than 1, what are those numbers greater than 1?
2, 3, 4, 5, and 6.
So that's why when you get a complement, it's going to be 0 and 1. And 0 and 1, those are less than or equal to 1, right? So now we will be able to solve this. 1 minus p less than or equal to 1. So that is 2 minus binom CDF, because that is less than or equal to 1. So try that again. Second var is binom CDF, and you will see trials. P. So again, you have 15 minus 3, and the x value is 1 minus that, 1 minus second vars, binom CDF. What is the answer? Point 96. Any questions so far? No questions? OT. Between 1 and 4. Inclusive, so meaning including 1 and 4. So meaning you need to get 1, 2, 3. How are you going to compute this? What do you think? If I give you this problem, how are you going to compute these probabilities between 1 and 4?
Do we compute the probability and then add them all up?
Yes, that's correct. But it's going to be a long one, right? But that's correct. You can get probability using binom PDF, binom PDF of 2, binom PDF of 3, binom PDF of 4. Okay, I'll show you. You can use, this is your X. X. So you can use a binom PDF of 15.3 and 1 here. This one is binom 3 and 2. This one P. You will get the correct answer. But that's a long one, right? What if it's like between 1 and 9? So there's another way to solve this. So instead of getting each probability, so we know that we have binom CDF. Binom CDF is for less than or equal. So since the last number is 4 here, if we want to get P less than or equal to 4, what's the difference between these P1, P2, P3, and P4 and this? What do you mean by, again, less than or equal to 4? What do you mean by less than or equal to 4?
It's the same, but it includes 0. So 0, 1, 2, 3, 4.
Like 0. So the difference between these two, you have 0 here. This one you don't have a 0. So meaning you need to remove this 0 for them to get the same answer, right? So what you need to do, so for letter D, all you have to do is P less than or equal to 4 minus P of 0. Do you agree? Because less than or equal to 4, all you have to do here is use binom CDF. You're going to get 15 minus 3, 4 here, minus P of 0 exact. So you use binom PDF of 15, 0.3, and 0. And you will get the answer here. So try that, two binoms, binom PDF, CDF and binom PDF. So second bars. Binom CDF 15.3 and 4 minus binom PDF 15.3 and 0, and you'll be able to get the answer. Yes, that's correct. 0.15107. Okay. Any questions? All right, so no questions. And last one, compute the mean and the variance of a binomial random variable. And we have the formulas here. This time you need to have a copy of these formulas. For the mean of x is always n times p. Just like the last example, given n is 15 with a probability of 0.3, so you just have to multiply those two to get your mean of x. And then variance, np times 1 minus p, and standard deviation is square root of the variance. So copy this. You're going to need this for your tests. have practice here. The probability example that a new car of a certain model will require repairs during the warranty period is 0.15. A particular dealership sells 80 such cars. Let X be the number that will require repairs during warranty period. Find the mean and standard deviation. So the given here, probability is 0.15 and is equal to 80. And then you will be able to solve for the mean. That is, remember, it's n times p, so 80 is equal to so. And then for the standard deviation, is equal to the square root of np times 1 p. So 80 times 0.15. 1 minus p, the complement of 0.15 is 0.85. So compute that. What is the answer? Yes, that is correct. So again, don't forget those formulas to solve for the mean and standard deviation for binomial distribution. Any questions? All right, I have there's a question here, more or less. Those are two different things. All right, so again, if you have any questions, you can always, if you're shy, you can use the chat, and I will answer the question. So there's a question: how do you find the x value for a more or a less than x value? What is this? So those are. Right, so remember binom CDF is use of binom CDF is for less than or equal to a number. Binom PDF is the exact number. So let's say a probability of less than or equal to 5. So you use the binom PDF, binom CDF of, let's say, your n is 15, your probability is 0.3, and then this is 5. So this is your x of 5. So what do you mean by more or less? if, and let's say, I'll just give you an example. Let's say if you want to get a probability of more than 5, meaning that is greater than 5, greater than 5, wait, oh, your question is when the numbers are, oh, from the previous example. Okay, so between 1 and 4. So between 1 and 4 inclusive, meaning 1, 2, 3, and 4. So again, this is probability of 1. So you can solve that, compute for each probabilities, or you can either get probability of less than or equal to 4. But we know that less than or equal to 4, that is from 0, 1, 2, 3, 4. But since you only want between 1 and 4, you subtract probability of 0. So that's why you use binom DF here. And binom DF to get the answer. Okay. Any other questions? All right, and that's it for chapter 6. Any questions? Chapter 6. So we're gonna have practice tomorrow. If I were you, you can try to read those problems from the book, and if you have any questions about any of those problems, you can ask me tomorrow or anytime. And but again, we're gonna have practice tomorrow for your test. Okay. If you don't have any questions, I'll see you tomorrow.
Thank you.
Thank you.
Thanks.
Anthony Nagilian Macker.